Hello everyone, let's take a look at our next problem. In triangle ABC, angles A and B measure 60 degrees and 45 degrees respectively. The bisector of angle A intersects BC at T, and AT is equal to 24. The area of triangle ABC can be written in the form A plus B times root C, where A, B, and C are positive integers and C is not divisible by the square of any prime. Find A plus B plus C. Okay, so we're drawing a picture immediately. Okay, we can of course complete the final angle here, which is 5 pi over 12. That seems a little strange. Right? 180 degrees is a triangle, which is pi. Pi minus the other 2. Two pi over 3 minus pi over 4. Multiply by this by 4. Multiply by 3. Okay, fine. 5 pi over 12. We have the bisector of angle A. So this will become two angles. Pi over 6. This is the point T. AT is 24. The area. Okay, so we're given the area of ABC. Basically, we're not given the area. We're basically asked to compute the area of ABC. So of course, we can find what both of these angles are. Is it worth going through some path of using trigonometric stuff here? If I can find this height, oh wait, no. I really hate these geometry questions. They're so annoying. Wait a minute. I haven't drawn it well, but I believe both of these angles are in fact right angles. I've not drawn this diagram to scale at all. But oh, no, I lied. Maybe this will help a little bit because this triangle is isosceles. So that means this side length here is 24. I'll write the side lengths in this color. And what is this angle? It is 7 pi over 12. So I should be able to find the height of this triangle somewhat easily. How does the sine law work? 24 divided by, okay, I'll write this as sine of pi over 4 divided by 24 is equal to sine of pi over 6 over x. So x is equal to 24 sine pi over 6 over sine pi over 4. Come back to what the numerical values of these sines are later. And for y, should be able to do something similar. Sine pi over 6 divided by y is equal to sine of 5 pi over 12. I don't need x and y individually. I need x plus y. or at least this will work if I know x plus y. I'm going to do this differently. Okay, I want x plus y and I want the height. The height I'll call h. We'll solve for that some other way later. Okay. So sine of pi over 3 divided by x plus y is equal to sine of pi over 4 divided by 24. The way I'm going to solve for the height is by dropping another perpendicular here and looking at this right angle triangle. So sine of 5 pi over 12 is equal to h over 24. Okay. So the area of the entire triangle is equal to h times x plus y divided by 2. I'm missing a 24 in here. So h is 24 times sine of 5 pi over 12. X plus y divided by 2 is 12 times sine pi over 3 divided by sine pi over 4, which I'm a little surprised. I would have imagined all these have like a root in them somewhere. I'm just going to check some of the geometry stuff that I've done, make sure I haven't done something silly. Okay, so now it's just figuring out what these sine ratios are. I never remember these. I guess sine pi over 4 is easy, right? Because that's for an isosceles right triangle. Sine of pi over 4 is 1 over root 2. Since sine pi over 3, I know that it's like it's formed by the, what is it formed by? The 1 root 2 root 3 triangle. So if this is pi over 3, this is pi over 6, how does this work? 1 root 2 and root 3. Oops, yeah. So let me just make sure this works, right? 2 squared to 2 plus 1. Yeah, all right. I think this is these are the right ratios here. So then sine of pi over 3 is root 2 over 3. Yeah, okay. And what about sine of 5 pi over 12? So I'm thinking here maybe using like double angle / half angle formulas. Okay, I have finally come to an answer of 590. That is a plus b plus c. I'm not going to go through this in too much detail in terms of trying to check the work myself, because this was such a tedious and annoying problem. But I mean, a brief outline of what I end up working out here. Sort of breaking down the geometry of this triangle and how things work. I realized that to write down an expression for the area, I need this base multiplied by this height, divided by 2, of course. And then just using a bunch of trigonometric identities to write down what the length of this base and the height are. One of the most annoying parts of this whole problem is that one of the angles we have is 5 pi over 12. I don't have memorized what the trig ratios for, multiples of pi over 12 are. So I ended up deriving that by recognizing 5 pi over 12 is equal to pi over 4 plus pi over 6. Pi over 4 plus pi over 6 is 5 pi over 12. So we have the angle sum identity for sine, and all of these coefficients, all these trig ratios. I don't want to say I have them memorized, but I sort of know how to find them somewhat easily. They're all in terms of root 2, root 3, and so on. And then I hope I just did all the rest of the arithmetic here. But I'm not super confident in my answer. It's possible I made some mistakes in the arithmetic, but at the end of the day, the final answer I have here is an integer between 0 and 999. This being the AIME exam, it satisfies that condition. And I did see that the area of the triangle could be written in the form specified by the question. So that worked out. Yeah, I'm going to say that this is my final answer, but if I find a mistake or if I have more comments about this one, I'll put them in the description. Thanks for watching.